quantum mechanics in action would be like if you took a handful of chopsticks or electrons and threw them into a drawer, which is our system, and shut the drawer. Nature would efficiently take account of all the chopsticks and optimize them based on shape and size. So let's say it takes account of like some chopsticks are longer than the others, some of them are up, some of them are down, and nature just magically organizes them to fill the bottom of the drawer in the most perfectly snug orientation. And voila, you open the drawer and everything is neatly organized and the space is wisely filled.
It's like Mary Poppins.
Yes. Yeah, nature is basically Mary Poppins.
Yeah. Welcome back to the Tool for This Shit podcast. I'm your host, Angie Sorensen. If you're new here, welcome. And if you've been listening to me before, welcome back. I am so glad that you're here. This is an interview-based podcast where you'll find a wide range of topics and guests such as doctors, sex workers, women who escaped Christian cults, scientists, psychotherapists, coaches, divorce lawyers, and many, many more. It all started because I was so mad that I was learning lessons after 40 that I felt I should have known when I was 18 or that I wish I had known at 18. And it's still a part of it today. But I realized that the better word to describe the theme of this podcast is discernment. Look, I've been told enough times that I am opinionated and passionate, but I do know inside that a lot of life exists in the gray, in the in-between, and that none of us really know what the truth is. And my aim is to bring guests on that can help open up those conversations. I am not here to tell you what to do. I definitely could be wrong on every single thing I say. But what I really, really want is that together we have some aha moments, a good giggle here and there, not take ourselves too seriously, especially when things and conversations are difficult. I'm not ahead of you. I'm walking next to you and I'm just learning as I go along. So I want to give you a little update on what has happened since the last episode last year. In June, I reluctantly paused the podcast because I was doing too many things at once with a full-time day job as an assistant, setting up my membership and doing the podcast. I was just spread too thin and I felt I wasn't getting anywhere fast. I was burning out. And if I carried on this way, I was worried that nothing was going to change. So I paused the podcast so I could focus on setting up my podcasting membership, which now the foundations are up. It is where I help creatives and brands use podcasting as a way to share their insights and grow their brand. It's called Get Your Podcast Done. Obviously, link in the show notes. But so now that I have set up the foundation, I can record episodes again, and I am so happy. It still feels busy. I'm still busy. But a lot of my brain capacity is back on this because I've set up the foundation. And so it really, really, really helps. So it will be really interesting. But for me, I'm interested in seeing how things are going to pan out and how things are going to work out in a year's time. So I am here. I am still here. And I am still recording podcasts. And I love interviewing people. I absolutely love it. And so this season, we will cover new topics, discover new guests. Some of them are a woman who climbed Machu Picchu on crutches, the rights of sex workers and their role in society from the only woman-owned brothel in Nevada, how the beauty industry, Hollywood, and social media have hypnotized us and influenced our self-perception to prompt extreme measures via cosmetic surgery, like facial restructuring in your 20s, without medical need for it, in pursuits for perfection. I also have a guest whose quote is, "I'm increasingly convinced that it's healthier to consider normal to be insane." And hopefully many more topics to be revealed soon. So, today's episode, Lindsay DeMarchi is back for a third time. She's the intro for this season 2024. And as always, she delivers. I love chatting with her. I learn so much and we always have a good giggle together. So this time we are venturing into the profound realms of quantum entanglement and discuss what it means for how we perceive our realities. Has it changed or confirmed what we already knew without proof of it? This is an episode where we delve into the implications of this interconnected universe. So, without further ado, help me give a big, warm welcome to Lindsay. Let's begin. Hi, Lindsay.
Hi, Angie. The world has missed you.
Welcome back. Well, I've missed you, Lindsay. So this like people don't know, but we've been trying to get a time for quite a while. I think maybe over a year. I know I had a pause, but yeah, like I'm very excited. So thank you.
Me too.
Yeah. Thank you so much for joining me today, Lindsay.
Thank you for having me. I'm really excited for where you're going to take our topic today.
Well, listen, today is going to sound a little bit like sci-fi, but in 2022, a group of 3 scientists won the Nobel Prize for Physics because they, I believe, proved quantum entanglement is real when they conducted some groundbreaking experiments using entangled quantum states, which, don't worry, if you don't know what that means, me neither. But Lindsay's going to explain this in a second. But it's basically where 2 particles behave like a single unit, even when they're separated. So that's from the Nobel Prize, or somewhere on Google, I read that. But the 3 winning scientists, I feel like I need to actually mention them because without them, this episode would be very different. So the 3 winning scientists are Alain Aspect, John Clauser, and Anton Zeilinger. Thank you very much for your work.
Yeah, thank you.
Yeah. So the reason why I have you, Lindsay, on today is because you have this immense ability to explain complex science into digestible parts. And I would really love to discuss not only what those findings of quantum entanglements mean for science, but also what it means on a more philosophical, spiritual, personal level, basically.
Yeah.
Mm-hmm.
Yeah, beautiful.
Yeah. So before we dive in, Lindsay, please introduce yourself, where you live and what you do.
Awesome. Okay, so I am Lindsay DeMarchi. I am an astrophysicist, but I'm currently working on space policy. So I part-time live in Washington, D.C., and also live in San Diego, California.
The last time we spoke was in around maybe September 2022. So I know that you've been doing a lot of incredible work since. So can you tell us like what you've been doing since we last spoke?
Yeah, it's going to sound like I'm reading my CV, but I got my PhD, so now I'm a doctor.
Congratulations.
Congratulations. That was a milestone. And then right after that, I went to work for a month in rural Idaho. And I worked in the biggest I guess I should say one of the first dark sky reserves in the country, 900,000 acres of dark sky. I was their astronomer in residence for a little bit. And that was the best job I've ever had in my life, but that only lasted a month. And now I am on a 1-year fellowship in Congress, and I work in the US Senate on space policy.
So is that to stop like, I know, I mean, it's not PC to say, but is it to stop Musk like throwing all these satellites and ruining our view upstairs? Like, or people like him?
I should qualify. I mean, I am speaking of my personal opinion, and this does not reflect the opinions of my employers.
Yeah, of course.
But I very much would like to ensure a very safe and clean and dark sky. And that is sometimes at odds with the other things that are going on.
Yes, all the corporates and the money. Can you explain what dark sky means? Because you said you spent like a month in the dark sky, the first dark sky reserve, like in rural Idaho. Can you explain what dark sky means?
Yeah, that's a great question. And honestly, it's an evolving definition because traditionally dark skies just meant light pollution. And the first time I heard about light pollution, I was like, what the hell kind of like stay-at-home mom problem is this? Like, I was like, this is not a big deal. And I came to understand that actually, not only is it a huge deal, but it's a very solvable problem. It's not like typical pollution where we think about decades or eons for our water to become clean again or climate change to reverse. Light pollution is solvable like instantly. And the real issue, I guess, is that you turn a light on because you need to see presumably the sidewalk or the ground or a surface, and you have a light that is not properly shielded, meaning that you have excess light going up, down, all around. So a good example I like to use is like, if I'm in an airplane, why can I see your porch light? Like, that makes no sense. I don't need to stand on your porch. I don't need to find your front door. There's excess light everywhere. So if we just properly direct our light, like we do with water in a faucet, we solve a lot of light pollution problems.
Oh my God, it makes so much sense. Like, and I know, I went on your LinkedIn because you post about this, and like how basically the solutions, like you said, like they're not that complicated, but it's just like for some reason we're not doing it. And it's true. I never thought about it this way. Like, why can we see some? Like, I think we can see. I don't know if it's still valid today, but I know that back in probably in the 90s, you could see the motorways in Belgium because they're very well lit. They were very well lit back then, which is great when you're driving, I guess. But from the moon, you could recognize where Belgium was because of the lights on the highway, and that's just too much. That's just like, why? That's not needed. Also, do we need to buy signposted? We don't need to be signposting like where we live, like if people want like out in space, like come and visit us. We'll basically like have this, how do you call it? Like it's like a lighthouse, planet Earth, right at this point.
That's a very beautiful way to think about it.
So it does a dark sky reserve mean that basically there's no light pollution?
Yeah, and I think a common misconception is that like that means no one uses their lights. That's not true. It's just that we have, in the towns surrounding the dark sky reserve, there is an ordinance for proper lighting, which means that light that is properly shielded and not scattering all over the upper atmosphere. I have to say that the towns around the dark sky reserve do a fantastic job. And I lived in those towns and I never felt unsafe. I never felt like I couldn't see what I was doing. It was a really beautiful example of things working very well. And what was crazy was I hiked into the more remote parts of the reserve, and the light pollution that I saw was from a city that was over 2 hours drive away.
Yeah. I mean,
so it travels very far.
It also tells you like there's also, we probably use more electricity or resources by having ill-fitted lighting in that way, right? Because if we only need it for, like, we don't need it to be, well, maybe that's not actually correct, actually. I'm just trying to think now. Maybe I'm thinking it wrong. But
I think you're on the right track. Like you're wasting light, you're wasting energy. Like another example I could use is if I was trying to fill a cup with water, and instead of using my kitchen sink, I just had like a naked pipe jetting out of my wall, and I turn the pipe on and I just like hope some water lands in my cup, but I've like drenched my floor.
Yeah. And use like a lot of liters instead of just a cup.
Yes, exactly. So there are actually, you're totally right. There are some estimates that cities could save or countries could save billions of dollars a year if this problem were resolved.
Oh my God. I mean, that's just insane to me. Like, why that's not in place already? Exactly. I mean, they do it here too. And I think it's also, it would help as well, like, not because I have like street lights outside my flat, and that comes, that flows through my windows. And it's like, it's things like that as well. It's also annoying for like just people who live there around all these lights. It's just not healthy, I think.
You're absolutely right. And I think most people don't know they can change those things. Like, I think we're just very adaptable as humans. And we just think, oh, this is the way it is. Guess I'll get, these new curtains or whatever that block the light out. And no, you could talk to your town about changing that.
Yeah. Well, let me talk to the bar in London. I'm not going to say which one I'm in, just in case. But, I probably should. I probably write them a little letter, a little email. Because it's just stupid at this point not to. So just one last thing about this dark sky. because I
Mhm.
love seeing the stars at night, which obviously in London is just like impossible. Like sometimes I keep seeing this really bright star next to the moon. I'm like, is this a satellite? Because I know Lindsay mentioned these satellites. Like,
Mm.
or is it like, or is it the North Star? Like, I don't know now. But we don't really see many stars. But when you're in that dark sky reserve, I bet stars must feel like they're right in front of your eyes, right?
Oh my God.
Yeah.
So I'm 30 years old. And like I said, I just finished my degree in astrophysics. And this was the first time I ever saw the night sky. And
Wow.
I cried. Like I had never seen so many stars, but at the same time, it was like sad tears that turned to angry tears because I realized that if I had had this my whole life growing up, I don't know if I ever would have felt alone. Like it felt like
Yeah.
I finally understood some of the older cultural relationships to the sky. It felt like I felt truly held by something larger than me. And every night, seeing those stars again and again, I started to get a familiarity with where they were in the sky. I could see constellations more clearly. And I felt just truly held by the whole universe around me. And it really ignited my passion to bring that back to people because it is possible. If all of London moved their lighting to be dark sky friendly, you could see the Milky Way from London.
I mean,
I'll
that's
point
insane. Wow. Yeah.
it's
Yeah.
very doable. So Tucson, Arizona, which is a very large city in Arizona, changed all their lights to be dark sky friendly, and they can see the stars there. So it is possible in cities.
Oh my God. I mean, the thing is, it's funny because I mean, I know exactly, I mean, just from like memory, but I think I know what you're talking about when you say, when you look at the night sky, because the first time I had this experience that I remember was I was camping in France in the summer. This was like going back
Oh,
over 15 years ago. And we stayed in tents, right? And in the, sometimes you have to like, I had to like pop out in the middle of the night outside
uh-huh.
my tent. And I remember it was like a shock. I felt like the stars were like at arm length distance. There was so many of
Oh,
them, and they really
wow.
feel really close, but they're not closer. They just feel closer because it's such a, it was like in the middle of nowhere. So there was no, cities were quite far away anyway. I don't know how far they were, but it was very isolated. And sometimes I see it also when I go back to Denmark, like it's out in the countryside. I really like used to call it the dark country because if there's no lights, you can't stretch your arms and see your hand. That's how dark it gets. So you
Wow.
can, like, if it's a clear sky, you get to see stars. But I don't remember ever being as strong as what I saw when I was in France
Yeah.
all these
I
years
bet you
ago.
could I bet you could see them down to the horizon.
Like, yeah, it was just packed. It was just so full of stars. I'd never seen anything like it. It was almost like dizzying. Like I almost felt dizzy because I was like, wow, I did not expect that. Did
You
not
know
expect
what?
that.
When I talked to people in the reserve about their own dark sky, almost everybody told me a very similar story to you, except they said, "Oh, when I get up to go to the bathroom in the middle of the night." As I
That's what I was doing actually. That's what I was popping out because I needed to wee. That's the only reason why I even want to go outside in the middle of the night, because I was like, I really had to go. Otherwise, I'd stay in my sleeping bag for sure. But I'm glad I got to leave to get out because that was insane, like that experience. And then there's no one around to say. I was like, I couldn't say, hey, can you see this? Like, yeah, it was mad. It was mad. Yeah, it was really good. Briefly interrupting the episode. If you want to solve the light pollution in your area but don't know where to start, Lindsay and I have created something for you. We've put together an email template. You can copy paste. You just have to amend your name, address, and so on, and obviously the name of your local mayor. But the text has been kindly provided by Lindsay. The link is in the show notes, and you will get it in the form of a PDF online and also sent to your inbox. Now, back to the episode. So, so before we get into the whole quantum entanglement thing, I just want to say, like, for to listen to Lindsay's like background story, how she got into this line of work in the first place, like please go and listen to, you can go and listen to episode 93, which is called Going to Mars and the Elon Musk Paradox, released on the 9th of October 2022. So I'm not going to go back into the whole background story, like, but it is really, really worth listening to her on that. So if you ever curious to know a bit more, go to the episode. But for today, we can just go straight into this. So, Lindsay, it sounds like a very fancy word because I think it is. But in layman terms, what is quantum entanglement?
Okay. So this will be the longest answer I give you. So please do interrupt me the moment I lose you.
No, you won't.
I will say extremely broadly, to understand quantum entanglement, we just need to tackle both words, quantum and entanglement. And I think entanglement is already very illustrative, things being intertwined. And maybe the most mysterious word of the pair is quantum, which is what the hell does quantum actually mean? Yeah. How is that a qualifier? How is that a descriptor? So I'm going to start out by explaining very broadly, what does it mean to view the world through a quantum lens? What is quantum mechanics, or the mechanics through which we describe the world around us? I think the most common, maybe not misconception, but thing that people don't quite know is that all of the world can be described using quantum mechanics, but it's like describing the entire world on a particle level. And sometimes that's just not practical to do. If we want to figure out the speed limit of a road, I don't need to get down to the nitty gritty of the atoms of the car. I need to know how the car itself moves and whether or not it's going to make it around that sharp turn. And so you may have heard the phrase classical mechanics, which is a different regime of when we talk about large things and large behaviors rather than atomic behavior.
And when you say atomic, is things like an electron.
Exactly. It'd be electrons, protons, bosons, fermions, if you've heard of these before. They're like Pokemon, but they're really tiny.
It's like at the atom level kind of thing.
Exactly. Yeah. That's so quantum. You'd have to think back to high school, probably. Mm-hmm.
Yes.
Yeah. But like I was saying, everything can be described with quantum mechanics. It's just that sometimes it's not practical. But by the same token, because classical mechanics is this generalization of large things, we actually can't use classical mechanics to talk about the small things. We can only use quantum mechanics. So the word quantum comes from the word quanta, which is a very singular small thing. I think it's a Greek word, quanta.
Yeah, it could be from Latin even, like meaning small, right? It's like super small particle.
Oh, is it Latin? I think I've embarrassed myself.
No, I don't know. I mean, I was just guessing. I don't know. I'll be quiet. I'll be quiet. No.
Well, either way, as long as it makes you think of the word small, that's the right idea. Then you get it. So, okay, what is quantum mechanics and why is it useful for describing the world at all? The easiest way to answer that question is to say that nature, just in general, has an order that it goes about things. It prefers things to be low energy. It doesn't really like disturbances. So nature has a strict set of organizational rules. And a good example of this is your silverware drawer and the way that you pack your silverware drawer. So you fill up knives, forks, spoons in their designated slots and in order so that they stack on top of each other neatly. You're trying to do this efficiently so that you can actually close the drawer when you're done. You don't just throw them in wholesale, because if you did, you would have forks sticking up everywhere that's inconvenient. And I know because I do that currently. So nature organizes tiny particles like electrons in a very similar way. Except instead of thinking about their shape the way we do with silverware, it thinks of things in terms of energy and spin. So the best way to equate energy and spin to silverware is to think of chopsticks. I'm going to apologize.
Well, but I love that example, by the way.
I was literally about to apologize for that.
No, because that's actually great. Because I know, because you sent it to me, and I absolutely love it. I was like, when you send it to me, like, just don't worry about it. Like, it's actually a really, really good example. It makes it really easy to understand. So
Okay,
go
awesome.
for it, for sure.
So if we really think about the shape of a chopstick, there's like a tapered end and a thicker end. Okay. And if we want to put a lot of chopsticks in a drawer, probably the best way to orient them is to have them kind of in opposite directions to one another. So you've got the thick end of one up against the thin end of the other, up and down throughout the bottom of the drawer. Is there a better way to describe this, Angie?
No, I think no, that's it. That's right. Like it's like you have a thinner side, and then you have a thicker side, right, of a chopstick, and they basically like 69 each other.
Yeah, exactly. That's how they all fit together. Yes. So you can describe this up down as spin of an electron. It's literally just if it's pointing up or down. And so nature will pack electrons into a broad system. And by system, I mean the drawer, a room, a box, a star, by filling the lowest energy states first, which is the bottom of the drawer, and then piling up on top of each other little rows of these neatly organized, perfectly matched chopsticks so that you fit as many in there as possible.
Yeah.
So that, I guess, in a nutshell, is what quantum mechanics is describing, is how nature decides to organize things put together. But it goes a little bit further, which I'll get into. So quantum mechanics in action would be like if you took a handful of chopsticks or electrons and threw them into a drawer, which is our system, and shut the drawer. Nature would efficiently take account of all the chopsticks and optimize them based on shape and size. So let's say it takes account of like some chopsticks are longer than the others, some of them are up, some of them are down, and nature just magically organizes them to fill the bottom of the drawer in the most perfectly snug orientation. And voila, you open the drawer and everything is neatly organized and the space is wisely filled.
It's like Mary Poppins.
Yes. Yeah, nature is basically Mary Poppins.
Yeah.
So a tiny detail of how nature does this is quantum entanglement. When nature examines a pair of chopsticks or electrons in our messy situation that we started, how does it decide which one goes up and which one goes down? Especially if the chopsticks are identical. The answer to that question is both chopsticks are both up and down at the same time until you open the drawer.
Is this related to the same thing that, was it like Schrodinger's cat or something, like when like the cat is in a box and it's both dead and alive? Is that what you mean by like they're both up and down? And obviously the chopstick is an example. It wouldn't be actual chopstick. It wouldn't work with chopsticks, but it would work. It's at a particle level, like electrons, atoms, and things like that out in the universe, right?
Yes. So yeah, now you're exactly right. Schrodinger's cat is kind of I don't want to say sarcastic, but it's kind of a sick interpretation of the same thing, the same phenomenon. If something is both two things at once, what's the most crazy example I could come up with? Well, something being both dead and alive, because it makes no sense until you open the box and you force it to choose one. But exactly. So nature does this with electrons everywhere and photons and other particles. If it doesn't make sense to you, then you understand it perfectly. This is really weird.
Yeah, it is, because you're like, how does it, because I guess like in my head, I'm like, what does that mean? Like, how is this a thing? How is this proven? And two is like, what does that mean in our everyday life? It's just like, but I may be getting ahead. So but it's like, it's really, really like a mind cluster.
Yeah, I think what was a struggle for me when I understood this was, how do we describe the world? I mean, I told you that quantum mechanics can describe everything. So how do you describe things in such a generalized term? Like, how can you describe everything as being these conflicting details all at once? And so I'll broadly say that quantum mechanics as a whole is a way of describing the world using probability. So here I was talking about our chopsticks as being both up and down because they're identical to each other. There's an equal probability that they could be up or down, either one of them. But if I was to use quantum mechanics to describe my routine in the morning, it would sound more like I wake up and there's a 90% chance I'll have eggs for breakfast, a 5% chance I'll have cereal, a 4% chance I'll have an apple, and maybe like a 1% chance I'll have a donut, which is kind of crazy because I don't have donuts in the house, but I guess it's not outside the realm of possibilities. And until I eat breakfast, all of these things are true. In fact, every tiny other possible, I could eat a car for breakfast. I could eat my cat food for breakfast. I could eat anything for breakfast. And until I have done it, I have eaten everything for breakfast.
Yeah.
Yep. Go ahead, Angie.
Yeah, so it makes it because like, you know, like you said, like quantum mechanics is like basically like when you wrote to me, you wrote like quantum mechanics measures the world in all possibilities of what can happen. So in my mind, it's like, does that just mean it's like, because obviously, like until you made the choice, so you could be having eggs or a car or toast or cereals or just an orange juice, right? But then at some point, poof, you make a decision, and then all the other options like evaporate because you made a decision you're gonna have eggs this morning, and that's it. But it's almost like it's almost like it means like I'm not sure if I'm kind of like getting ahead because I'm thinking of like the quantum entanglement part. So let's talk about that because like you've mentioned the chopsticks and how basically like the chopsticks, they're just going to be ordered in a specific way, right? They're going to be really nicely tidy, like Mary Poppins has come over, and that part is quantum mechanics, right?
Yeah, so it's almost as if I see where you're going with this, where you're like, I know it can't exist in all of these possibilities. Something must happen. And I will tell you, which we'll come back to, in your question, you have just invented the multiverse theory.
Yeah.
So
I mean, I didn't invent it, but it's definitely because I know like the multiverse, and we're gonna like because we're definitely gonna get into that multiverse and parallel universe because that has, I mean, the parallel universe has got to do with quantum.
Yes.
Multiverse is slightly different, right? But I guess like because I just want to let you carry on telling the story with the chopsticks because at some point it becomes then there's the quantum entanglement part, which is even more of a mind cluster. So
Yeah.
so yeah,
Yeah.
because so you've mentioned like that's what nature does, like they're all tidied up really nicely, and then what happens?
Yeah. So coming back to the breakfast example, let's just start with that one.
Yeah.
Until I've eaten breakfast, I've done all of these things equally. But then when I do go to eat breakfast, like you said, all those other options, poof. And the record shows I have eaten eggs for breakfast, and that's kind of the end of that. All of my possibilities have disappeared. And the jargon we use is we say the wave function has collapsed, which means my wave function is this laundry list of probabilities of everything that could happen. And it collapses down to a single result the moment that something happens. And in quantum mechanics, we have an observer. So when you and I open the drawer and the chopsticks are arranged, you and I observe the system, and all of that chaos condenses down into something neatly packaged. And the only thing we did was observe the system. I personally don't understand why that's the case. I don't know if anyone does. But that is the magic key, is
So
simply looking.
is this the thing that the fact that you look at it, all of a sudden, then a decision is made? Is it that thing like when like you could have a box with a ball in, but that's very, very small, like quanta size, so like an electron size. So you and I wouldn't be able to see with our naked eye, but there was like a ball in a box. And
Okay.
until we open the box, it can be any colors in the world. It can be full red, full blue, full green, any colors it can be, right? The minute
Yes.
we open the box, it becomes one color.
Yes.
And
Yes.
and it's basically the fact that we're looking at something makes it not necessarily more real, but it makes it decide on one option.
Exactly. That is perfectly said. That is
Right.
exactly right.
But
So
how does this? Yeah, go on. Sorry, go on.
were you going to ask about entanglement?
No, I just want to like how because all of these things we sort of discussed them in things like with chopsticks, bowls, and stuff like that, right? Because it's a way to describe something that I can relate to, right? That
Yeah.
anyone who's listening to can relate to. But what does that mean in the quantum world, the physicist world? Because obviously
Yeah, like
Unless
how
we're
does that
using,
actually
yeah, unless we're
manifest?
using a magic trick, that's not what's going to happen. If I buy a ball and I put it in a box, it's going to be that same color every single day I open up my box, right? If I buy a
Right.
ball in the shop, yeah.
Right, you're absolutely right. So the way that that actually manifests on a physical level is electrons in their spin, kind of like the original example I gave. But it can also be light and the direction of light or a photon on an individual scale. But getting into some of the more physical consequences, maybe on larger and more human scales, is actually going to be in the realm of quantum computing, which we can talk about in a moment. But I have to say that humans on a day-to-day sort of level don't really experience the effects of quantum mechanics. And as a physicist, the places that we encounter it are really on it's the places that I have personally encountered it the most as an astrophysicist is in using ways to describe the behavior of the universe and maybe why the universe came to be the way that it is. So it's kind of talking about the grandest scales on the smallest scales, talking about how electrons sort of organize themselves, whether it's in stars or whether it's in the Big Bang, so to speak.
But yeah, because I guess because everything is, because you have matter, right, in space. Like there's all this, there's
Yeah.
dark matter, and I think there's also dark energy or something like that. Now they talk about, but
Mm-hmm.
it's like, but there's all of this empty space is not empty; it's filled with things. So this is where like the quanta level comes in, right? The electrons or whatever the particle is. Like they have those things they call it. They also talk about it in sci-fi. There's the thing that comes out that's in the sun, the nitrons, the
Oh, Higgs boson?
no,
Neutrons?
the ones that we're constantly bombarded with, but we can't feel them.
Neutrinos.
Yeah, 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 and yeah, they have that in sci-fi. That's how I thought I could remember the word. Obviously, I forgot it already, but yeah, neutrinos. But so I think like, can we go into like where the quantum entanglement comes in, because that
Yeah,
box of chopsticks, which we're gonna we obviously understand is to do with like electrons and stuff like in the universe, but how does that go from quantum mechanics to quantum entanglement, because that's an
great
even
question.
more crazy phenomenon.
Yeah, so coming back to our chopsticks, right? You and I, start to finish, we throw a bunch of chopsticks just like willy-nilly into a drawer. We shut the drawer, and until we open it, it's in this liminal state of up, down, all around. And then once we open it, it is organized, and nature has chosen you go up, you go down, you go up, you go down, alternating across. So let's say you and I throw the chopsticks in a drawer, shut the drawer, and never open it. And instead, slip partition in the middle of the drawer. So we never open it, but we cut the box in half. And you ship half that box to me in the United States while you're in the UK. And you open your box. I don't. Okay.
Mm-hmm.
Whatever matching pairs I have in my box in the United States will flip and choose their orientation based on what you observe in your box in the UK. So let's say you open it and you've got a pink pair, a green pair, and a blue pair, and your pink one is facing up, your green one's facing down, your blue one's facing up. I have their matching pairs. Suddenly in my box, when I open it, I will see them in the opposite orientations. In other words, even though the particles are not together anymore, there is a memory of the fact that they were touching, that they needed to be up and down in their system. And you collapsing the wave function on your end has collapsed it on my end.
You see, this is where it gets really exciting for me, because the fact that this happens is because they touched once, right? They were once in the same drawer, right?
Yeah.
And this, to me, I don't know if I'm jumping ahead, but to me, this explains, that's how I relate to the way I relate to that information, is that it makes sense that when people have a sense of, oh, I need to call that person, I know something's going on, or I haven't heard from them, I need to check in, or some people are really good at, they'll be thinking about someone randomly and then that person calls them. So I
Yeah.
feel like that's kind of where, because I know you talked about, we talked about space and the electrons and neutrinos and all of these like tiny, tiny particles that you and I can't see, but we are affected by, right?
Mm-hmm.
Um, and in a way, it also reflects back to us because we're also made of tiny, tiny particles that you and I can't see,
Right.
but we are affected by them. It has an impact on us. And I think everything is energy, even like, the electric magnetic field, I don't know if you can explain about that, but like, it's the law of nature, right? Like you have gravity, that, and then you have two other ones with like, I don't know how they call them in English, like strong nu-
Yep.
nuclear power. No, what do you call it? Strong.
Strong force and weak force.
Yeah, which I don't
Yeah.
know. I don't understand those, but I know about gravity.
Yeah, that's fine. Strong and weak just hold atoms
Yeah,
together. That's all
and
you
I
got to
know,
know.
and I know about EMF, and EMF is like it basically stops us from like basically sinking into the earth. Basically, like we would just be like water, right?
Yeah.
So, and that's to do with electromagnetic field, which is an energy, right?
Yes,
Or
that's right.
right. So everything, even on a scientific level, is said to be energy. So the fact that we can hear or feel something that isn't tangible makes a lot of sense to me.
Yeah, and you know what? The most famous equation ever, E equals mc squared, is a mathematical way of saying all mass or matter is energy. It's on the other side of the equal sign.
Yes. Yes.
So you're bang on with that. And I think that my answer to that, like, how does it affect our intuition? How does it affect our relationships to each other? I don't know, but I do think that it is really profound to think that we are all connected in really profound ways. And like one of the things that was the most like spiritually life-changing for me upon learning about this is I thought about the Big Bang, which is the entire universe, which is parts of the universe that we will never see. We will never experience. The universe is that big.
Yeah.
But every force, every idea, but also think back to quantum mechanics, every possibility was all together in this singularity that then exploded. But what that means is that everything that ever was, ever will be, ever could be was all touching at the same time and then separated. And what that also means, and we can talk about this more when we talk about entanglement more specifically, what that also means is that things that I will never experience could affect my day-to-day life.
Such as, like, what do you mean by that?
Well, so let's get into that Nobel Prize.
Yes.
This is probably the best example. So how was that proven in layman's terms? Okay.
Yeah.
What would happen? This is a thought experiment that you and I will do together. What if I had a pair of entangled things like chopsticks, I guess, one pair, so 1 and 2, and then labeling them 1 and 2. And I had a second pair of entangled things. Let's label them 3 and 4. And let's say we don't collapse their wave functions. They exist in their up-down state, both of them. We don't look, okay? But let's take one from each pair and put them in a box. So let's put like 2 and 3 in their own box and make sure that they touch, okay? If I suddenly observe 1 and it's spin up, what does that mean 2 is?
Down?
Yeah. But if 2 is in a box with 3, what does that mean 3 is?
Up?
Yeah.
2 was, yeah. And so 4 is down.
And 4 is down.
Meaning that 1 and 2 have never touched each other, but they're still impacted because they have a second degree of separation, or 1 degree of separation. Is it 1
so
or
1
2?
and 4?
Yeah.
Sorry, 1 and 4 you mean?
Yeah, so like 1 and 4, they are 1 degree of separation, or is it 2 degree of separation? Do you know what I mean by like?
Yes.
They've never touched, but they know they've touched a number that's touched 1 and touched the other, something like that. Like
yes.
4 has touched 3, but never touched 2, but 3 has touched 2. See, this is why sexual partners is. That's why you gotta be careful. Do you know what I mean? It can get tricky very quickly. So 4 and 1 are impacted because 2 and 3 have gotten into bed together.
Yes, exactly. Exactly it.
That's actually very real, even in real life. Like if you are if you're in a relationship with someone and they have a tumultuous past relationship, don't you think it's going to affect you if they haven't like processed it in the way that's healthy?
God, yeah.
That's where entanglement comes in too.
It's like, it's like on a particle level, there's a memory. or an imprint
Yeah.
almost. And just
Yeah.
like people, we are so imprinted by our experiences.
Yes.
Yeah, that is a great way to put it. So exactly, the fact that 1 and 4 have never met each other, but their fates are intertwined.
Yes.
That is how, in a nutshell, the Nobel Prize was won, was proving if I have a controlled experiment where I know that nothing else is affecting 1, 2, 3, 4, and I put them in this system, just by looking at 1, I can predict how 4 is going to turn out. And that's how they did it.
And what did they use? Did they use like electrons? Is that?
I think that they used photons. And they predicted the direction that the photon would be in. So a direction is a lot like spin. In this, it's called polarization, which is a jargon word. But like if you've ever used polarized sunglasses, it's that same concept where there's like a direction in which the light's coming in.
Is it like, there's like there was like a school experiment, or I mean, I didn't have it, but like, I think it's something you can see on YouTube or something. Like when you put like, it's not, I think of a light, but I don't think they use that. I think they use like maybe like electrons, where it goes through one hole. There's a board, and then there's a wall, and in that board they do a slit, and then they put something through, and it reflects on the back wall. But then they do 2 slits, and instead of having 2 reflection on the back, let's say if it was light, instead of having like 2 dots on the wall, because there's 2 slits, there's something like there's more than one, but they don't use light. This is why like it doesn't make sense when I explain it. But instead of having like 2 dots, there's like more than 1 dot, and there's something to do with, I don't know why I was thinking about that based on what you just said, but I wonder if that's what you mean by.
It is.
Obviously, okay, because something is affected. Oh, yeah. How does it relate? I've lost my own train of thought.
It gets after the idea that so light can be polarized, but it also gets after the idea that a particle can, or light, it gets after the idea of all of these many possibilities before the wave function is collapsed.
Can you say that again?
It gets after the idea that there are many different possibilities until the wave function is collapsed. So the experiment that you're describing is called the double slit experiment. And what it means basically is that you would expect light coming through a slit to be in a very specific location. And it's not. It looks like it's actually spread out everywhere. And this was a groundbreaking experiment because it determined that light acts like both a particle and a wave at the same time. Because if light was just a ball going through that slit, you know exactly where it would end up on the wall. If it was like going through a filter or something, it should end up in one spot. And where you were describing, wait, why isn't it one spot or 2 spots and it's kind of all over the place and that's the magic? Well, that's light acting like a wave. A wave is spread out over space. It's not just one little tiny dot. It is spread out in many locations all at once. And that was the groundbreaking discovery, is that light acts like both a particle and a wave.
Is it like when you have a torch, it doesn't just go to, unless it's like a specific design, like it will light up more than just the size of your torch, right? It will light up, like you could see a room, like, or some of the room, right? Not just like a tunnel. But if you use an infrared light, like you see in the movie with the snipers, and it's a dot, right? So it's like is that different?
It's different, but that works on a metaphorical level of like the difference that we're describing. The reason light acting like a particle and a wave, I guess it is meaningful, is because a wave has properties that, I guess the best way to explain it is like, if I asked you, where is the wave? A wave is like a wiggly sort of thing. And so if I asked you, tell me the exact coordinates of the wave, you'd be like, what part of the wave? It's a wiggle kind of all over the place. It's like a roller coaster. It's like asking where is the roller coaster? It's like, it's kind of everywhere.
Yeah.
But if I asked you, where is the particle? You would point to the location of the ball and say, it is right there. So it's kind of a spread out over space. And this is why your metaphor actually works very well, which is to say that like you could spread out all over a room, or you could have like a very defined laser. I just don't want to be confusing using light as both the metaphor and the subject, I guess.
Yeah. Is that so in this, so because obviously so quantum mechanics obviously is all the possibilities, like, like a ball could be any kind of colors, but the minute you look at it, it makes a decision. Quantum entanglement is where you have, let's say, two balls who were born in one box, and then you separate them, but because they were in contact with each other, they are going to affect each other
Yeah.
no matter how far they are, right? So
Yeah.
Is this like, how does this like, does this have, so is this basically the reason why they decided to look at this and prove this? Is it because it's to show how we are impacting the universe is impacting us? Like, how is this in a scientific way? Like, why is this of relevance? I mean, I think it's super interesting, but where is the relevance?
Yeah, I think that part of the reason this ever came about was because, theoretically, this was determined. And even Einstein, he's the one who called it spooky action at a distance. Einstein didn't believe that it was possible. So I think this is one of those good old-fashioned examples of like, the math says this is true. And other people are like, that could never happen. And then everyone's like, okay, bet, like, let's find out.
Yeah.
So I think that was where the relevance really started, which is to say, just trying to understand the fundamentals of our universe and our forces was kind of, I think, the playground for which this was born. But it has become useful when we talk about, for example, quantum computing, because if we came back to our entanglement example, where I look at 1 and it determines the fate of 4, I mean, that happened instantaneously.
Yeah.
And we could have an infinitely long chain. And so people thought, maybe we could speed up computers. What if your app could download instantaneously?
No, I'm listening. I'm trying to think like, right.
Yeah. I was waiting for a question. That's why.
No, I don't have a question on that one.
Okay, yeah. So people look at quantum computing to say we can move things incredibly fast because it travels at this speed of, information.
Yeah.
And the great thing about it is what is entangled, it's not chopsticks, it's light and it's electrons. And when it comes down to our computers, this is the way information is spread. You can encode information into light or electrons. And so what you're doing is moving information incredibly quickly. The other thing is that you can store information in this superposition of states. So when we closed the drawer, we had so many different possibilities of what could be in there. Quantum computing says, what if we looked at all those possibilities and used that as a way of information storage?
And would it be like as well also like to make an informed decision?
It's all actually more of a way of saying, what if I maximize the storage space of my drawer by storing everything possible in it? Because when you open the drawer, nature decides to nail everything down in this up-down scenario, and it reduces things to the bottom of your drawer. Mm-hmm. But before we open the drawer, when we leave it in that sort of chaos, we've got like infinite possibilities. So what if I stored all of your images in infinite possibilities? How much RAM, or not RAM, I guess, how much memory would that free up in your laptop if we saved all of your images in this sort of chaotic state, as opposed to the amount of memory we have when we actually look at it aligned on the bottom of the drawer?
So you're saying like if they were stored in a neat way, like the chopsticks were, that's where we're saving the space. Is that what you mean?
I'm saying, yeah, actually, that's a really great way to put it. When we save things neatly, like chopsticks in the bottom of the drawer, there's a finite space. We are limited by how much space the bottom of the drawer gives us, but we are not limited by anything when it exists in that chaotic state.
When you're saying that chaotic state, is that when they neither or the chopsticks are up or down, or?
Yes, exactly. When they are everything all at once. Yes.
So when they're everything all at once, in my head, it would mean it uses more space, but you say it doesn't.
Well, the drawer doesn't change in size. But you're right, it uses more space because it's using all of the drawer.
So when you talk about quantum computers, Is that, are the computers, do they look different? Like, what are they used for? I don't understand that bit.
Yeah, so I actually have never seen a quantum computer, but I
No,
have
I've
friends who
heard
have
about
worked.
them, but yeah, I've no idea either. I'm like, yeah, go on.
Actually, yeah, like you would be the expert on that.
No, but no, I mean, I know of people who've invested in it, but I
Okay.
don't, from years ago, but I mean, no, I don't know. I just don't understand it.
Yeah, I think the what I should have probably made more clear is that in my chopsticks example to computers, that sort of bridge would be, instead of saying drawer, what if I said memory chip or something like that? What if the drawer was a symbol for the amount of memory that's possible in my computer? If I keep things in a superposition of states, I haven't actually assigned it to a slot of memory. I haven't actually forced it to choose.
No.
So you can, in theory, store more things in the same amount of memory just by keeping them in this superposition of possibilities.
Because when they're in a superposition, it means that they haven't taken a position yet. They're in all the position at once and in none of them at the same time, in a way.
Yes.
So they kind of live in a parallel universe.
Yes. Do you want to talk about multiverses and parallel universes right now?
Every day. Yeah, I love that kind of stuff.
So let me actually roll all the way back to the original comment you made about extra possibilities just going poof.
Yes, collapsing the wave.
Yes, collapsing the wave function. People believe that what if they don't disappear? What if they don't go poof? And instead, that's just a different universe where that actually happens.
Yeah, it basically opens into another portal.
Yes. Like if you think of life as a straight line, there are infinite other tracks your life could follow, and your life chose one over the other. But what creates that fanning out of tracks is this quantum superposition that you haven't chosen a direction. So there is a universe where I had a car for breakfast.
Yeah.
Yes.
Yeah.
So some people, I think the easiest example is to say in Schrodinger's cat, there is a future where the cat is alive and there is a future where the cat is dead. And both of those, because they are equally possible, they are equally real.
Or does it also mean that until you look at something, it's not real? But at the same time, we know there are buildings around. Like, just because I turn around and look at my neighbor's house doesn't mean it wasn't real before, or was it? But is it like the thing with the cat, Schrodinger's cat, or the breakfast possibilities? Is it because the fact that the fact that you've made a decision, you've made a focused, intentional outpour of energy onto it, makes it real, has materialized it? So it's in a way almost like, is it like it almost like spills over into like the whole woo-woo of manifestation, right? Like visualize it, make it happen, take inspired action, all this kind of stuff, right?
Yes. I have to admit that very much internally, personally, that is how I think of manifestation.
Yeah.
That is spot on. And it's funny too, because, you know, like, I guess saying like there's infinite possibilities, or you don't know until you try. I mean, it's very physically true.
Very physically true. It's almost like scientifically proven. But it's, at the same time, it's also actually quite simple, right? Because it's like the thing with the manifestation. It's like you can say any outcome in your life is undecided.
Yeah.
And there's unlimited probabilities depending on what you choose every single moment of your life.
Yes.
Basically proves our own sovereignty, right? And I'm not saying you can control like an earthquake. Things are gonna happen, right? There's outside stuff you can't control. You're not necessarily manifesting it on an individual level, right? But something has manifested it in some way, right? The earthquake, the volcano, something has made it happen. But again, you still have a choice of what do you do in that moment, right? Do you run? Do you fight? Yeah, right. That sounds dramatic, obviously, but it's just to say, like, even like when there's not these external dramatics happening, these tragedies happening, when if your life is like pretty zen on a day-to-day basis and you don't have war and things like that, every decisions you make, it's a very bittersweet pill to swallow, by the way, because that's something I've come to realize like years ago. I was like, oh my God, the reason why I am today is of every single decisions that I've made. There's no one else to blame.
That is
Life happens to everybody, but your decisions are yours.
But what I would offer is that it also means that everything that you have or have not ever experienced is very interconnected. And so not in a way to pass blame or pass responsibility, but it is also to say that those probabilities are constantly recalibrated based on the behavior of things you've never experienced.
Can you explain?
Yeah. So if we come back to our entanglement example, 4 and 1 never met each other, but they influenced each other. Just like you were saying about sexual partners, they've influenced each other. So, before 2 and 3 ever met, 1 and 4 were just living their lives, and they thought that they had a set probability. I am going to be very sure that I'm going to be either up or down. Mm-hmm. But then when we paired up 2 and 3 with each other, it changed the probabilities of 1 and 4 kind of instantly.
Yeah.
Because the moment that we opened the box of number 1 and saw that it was spin up, that changed things for number 2, and that changed things for number 3, and that changed things for number 4. Mm-hmm. So you could argue that it was never 4's decision to be up or down. Maybe it was their decision to be paired up with number 3 to begin with and all of 3's choices. But it changes the probabilities of what 4 can become based on 1's behavior. So in a sort of metaphysical sense, the decisions you make day to day, it's very much the butterfly effect.
Yeah. No, do you know what? This is so interesting because actually, there is like the previous thing, there's sovereignty in it. But actually in this one, there is how important how your little actions every day make, right? It's like,
yes.
Like, cause I mean, I'm going to share something like it's like a personal belief of mine, right? So always a principle or whatever you want to call it, right? But I hate virtue signaling. Like, it's just something like I've always had an allergy to it. Like, I'm not one who's going to put a flag on my social. I'm not saying it's good or bad. I'm just saying this is just where I stand, right? I'm not one who's going to put a flag or a symbol or whatever it is, or wear a logo saying like a political statement, things like that. It's just not it's never been my thing. Because to me also, what I believe is I believe that I don't necessarily make a change by telling everyone what I think is right or wrong. And I know I've got a podcast, but I'm not telling people, I'm not telling people, vote this way or vote that way or sleep with this person. Or, you know what I mean? I don't do, but I believe that this is why I don't watch the news, because I'm very sensitive to it. But like for me, that is not where being super informed about what happens in the world does not affect me in a good way. I become very miserable, very anxious, very angry. Like it really affects, like there's so much stuff that's going on. And the thing is, I'm a worse person for it on a daily basis, right? Whereas if I take distance, like my impact is through my actions every single day. And some days I fail and some days I've just about passed, you know what I mean? Some days I'm like, okay, today I was kind of decent. And some days I'm like, oh my God, like, but it's like, it's through the actions. And I think because that is how, I think some of us, our impact is on a big scale. Like, you have the people who are out there, like the Mother Teresa's, right? Martin Luther King, all of these people are on a massive scale. And then you have other people and a whole spectrum in between. But there's people like me, like the smaller people, where it's like, for me, it's like on a daily basis, Am I nice to the cat next door? Am I nice to the next? Whatever it is, it's those little things. And those things have a ripple effect. I truly believe that. And I'm not doing it for the ripple effect. I'm doing it for my peace of mind and heart.
Yes.
But I feel that's where I've got the most. I don't have any influence by a flag I put on my social media, or I don't put it on. You know what I mean? Like,
absolutely.
That world to me is not real. Yeah.
Yeah, absolutely. And that I take that to heart. Like, that is why I make sure I smile at strangers, because you don't know how far that smile is actually going to travel.
Yeah. You do have to be careful with strangers, but yeah. In London, you do sometimes have to be a bit careful. Not gonna lie. Like, you gotta feel their vibe first. We'll see what's happening. Yeah, no, but I agree though. I do agree. I agree.
And I want to volley at you a philosophical question.
Yeah,
I'm really interested on your take. So, you could argue that by collapsing the wave function with your observation, where you gave the example of like your neighbor's house existing and not existing until you look at it.
Yes.
in a philosophical like parlance, that's very much existentialism.
Yes.
You create your reality based on what you observe. But at the same time, there is this sort of external to us constant recalibration of possibilities or probabilities at any given moment. It's like the floor is constantly shifting until you actually look at it. Does it mean that there is some kind of objective truth, but maybe not truth, objective probability? How much free will really is there? Is it a totally existential world where what you see and what you observe is reality? Or is it that reality itself is very fluid and it's almost like an objective fluidity?
Oh, that's a great question. Okay. So I actually think it's a bit of both, in the sense that every single day when I go to work, I get, I still have my day job. I'm still an assistant. I'm still someone's bitch. Sorry. That's what basically that means. Anyway, no, but I'm very grateful, and it's, and whatever. I'm not talking down on the job. I kind of I like to make a joke of it because I have issues with it. But yeah. So anyway, so long story. Yeah. So every single day, like, say if I have to go to the office, when I get ready in the morning, the shower is in the same place, the toothpaste is where I left it, the door is in the same place, I get out the house, I get the bus, the road is still there, those houses are still there. Touch wood. That's that. I get to the tube, and all of that is still there. So in a way, reality is fixed, right?
Yeah.
In that realm. But at the same time, I know there are some days I can get up and everything looks bleak. It's like it's the same flat, it's too small, there's mold in that one corner, the landlady is annoying me because she keeps wanting more rent, but she's not the place is, it could do with some work, I should be moving out. I come out, like, there's bloody the same fucking bus, I'm on that bus, the houses, like the area is a good area, but for me, it does not look, it doesn't have, I love nature, I love things being quaint, I love things being a certain way. I find the buildings here quite a bit depressing someday, and there's other days where it does not affect me, where I'm like, oh my god, look at this where I live, like, this is really nice, so reality is fixed and fluid. My perception of it is fluid.
Oh, that's a beautiful answer.
So there's infinite amount of reality. So I can get up and everything's bleak, and every actions I'm going to take are going to be inspired by this bleak place. And I'm probably going to end up being annoyed at someone, taking offense at someone, pissing off somebody else because I'm going to be snarky. And then, but if I wake up and I'm like, sunny side up, or whatever the expression is, I'm going to be smiling at most strangers. I'm going to be smiling at people I know. I'm going to be nice. I'm going to be more helpful. And all of a sudden, it's going to come back in return too. People are going to be nice. They're going to want to hang out. They're going to want to have a conversation, sit down, have lunch with me at work. They're not going to avoid me like the pest. They're going to want to be around me. And that in exchange is going to change my day, my outcomes, my choices. And that's going to shape my reality for years down the line.
Absolutely. It might even change your probabilities throughout the day because you were nice to that person. Maybe they'll tell you about this new job they heard about. You know what I mean?
Yeah. Exactly.
That is really awesome. The whole time you're talking about this, I'm like grinning ear to ear. I love this take. And just so all of your adoring fans know, I did not send Angie that question ahead of time. That was really out of her heart directly.
Do you have other questions?
No further questions.
But do you know what? Would you say that, because the thing with, because obviously, as in, like, I love sci-fi. So are you into sci-fi too? I don't remember. I've got a feeling you are. Were you?
I've come to realize yes, in a very strange way. I love He-Man, and I don't know if anyone would call He-Man sci-fi, but I would.
Is He-Man, it's probably more like fantasy. Is He-Man, I don't remember which one is He-Man. Let me just Google it. He-Man. Is it Marvel?
It's like the 80s.
That's probably more like fantasy, I would say. It's
I like
superhero, yeah.
But it's in space.
Oh, yeah. Okay, so it's got a bit of sci-fi then.
Yeah.
But I think, because obviously parallel and multiverse is very much in, Star Trek, I think, and other places. But it's actually, we know how quantum mechanics, when we were saying about how infinite probabilities, right? So the cat could be alive or dead. The ball could be red, blue, green, black, brown, whatever color, right?
Mhm.
That's actually, so it could be an infinite amount of colors, or you could have an infinite amount of breakfasts. But
Mhm.
until you choose it, until you collapse that wave by your choice, there's an infinite amount. And the minute you make that choice, those other amounts, maybe the wave has collapsed in this universe, but they've opened up in the parallel universe.
That's right.
Yeah.
Yes. Like you making a choice in this one changes the probabilities in all the other ones. So maybe it's that like me choosing eggs for breakfast in this universe removes the eggs option from all the other universes. And so maybe a car becomes that much more likely in another one.
And that's where 1, 2, 3, 4, that's the same example about how 1 and 4 are 1, 2, 3, and 4, how they're affecting each other, influencing each other, or however the word was, right?
Yes. Yes, you could look at it that way. Although I think what you would say in that case is one could have been up or down. And the fact that you chose up in this universe means that one chose down in the other one, which means that at the end of the day, let's see how that would go. Yeah, then 4 is down in the other one.
Yeah. And is that so? And then multiverse, right? Multiverse is something very different, right? That basically means that is multiverse, we had the Big Bang, but that means that there was maybe 2 minutes later another Big Bang, and that created another universe, and that's what multiverse is.
So I have to admit that I am not as fluent in like thinking about multiverses. The way that I understood it was that all of these different universes branch off based on our decisions. And like talking about all of them is the multiverse. And then just talking about 2 of them next to each other is a parallel universe.
Yeah, see, I wouldn't know if I'm not the right
I
person.
know people think about this much more deeply than I do. So I feel like I don't want to do them a disservice. Like I'm so scared that somebody's listening to this and I'm just like shitting all over whatever like careful work they've done just
their
by
research
being
and their 10 books they wrote.
Yeah, exactly. I'm so sorry.
If you have, send me an email. I would like to have you on. So talking about how everything is entangled, right? Like the 1, 2, 3, 4, all these different things, how everything is affected, and even though we would never have met this person on the other side of the planet, they may still be affected by our decisions today, depending what it is, right? So does that mean that quantum entanglement can never be broken? Could you ever break it? The entanglement?
I truly have no idea. Like, is your question kind of like, can we ever reverse a decision? Or is it like, can we force both of them to be up at the same time?
No. Okay, so you know what? This is where my question came from. So let me rephrase that. Basically, because I was thinking about how the entanglement and how we like how 1, 2, 3, and 4 were affecting each other, right? So I was thinking about, okay, so if we are entangled, because in psychology there's something called also entanglement between parents and children.
Oh, okay.
Like, you know how basically children, are very aware of the moods of their parents. It's part of their survival. You're genetically wired to understand exactly what mood your parents are in so that you survive, right? So do you need to be quiet? Do you need to cheer them up? There's maybe some are more attuned to it than others, I don't know. But I know I can walk into a room and I know exactly what mood, family is basically, right?
Yeah.
And so I was wondering about as well how, you can feel negatively impacted by people who are close to you, right? Some people are very negatively impacted by family, by colleagues, bosses. There's an impact that entanglement is creating.
Yeah.
And so I was wondering if from a physicist point of view, can quantum entanglement be broken, lifted? It's almost like a curse, right? It's like, like the juju or something.
I see exactly what you mean. Like, is there a way that we could separate? Yeah. I mean, like, if in our example where we had 1 and 2 together, 3 and 4 together, and then we brought 2 and 3 together, is there a way in which one can say, I don't want to be influenced by the fate of the other ones? Or 4 says, I don't want 2 to influence my life. I believe that on a very physical level, that there must be some kind of distance over which it no longer works. But I actually don't know if that's true. So the reason I say that is because I think that quantum computing as it is right now has a limited distance over which we can make it work. Which is like those chain effects. But I don't actually know if that is a technical limitation and not a physical limitation.
And when you say physical, do you mean like physical body, or do you mean like in physics?
I mean, in physics, I'm sorry. Yeah, like from the fundamental physics perspective. I don't know if, like, in theory, it covers an infinite distance and our technology just doesn't know how to do that. Or if, like, in the actual theory itself, there is a hard-coded byline that says, by the way, this will not work over 10 meters.
Yeah, no, because I mean, because obviously, like, we're talking about things or nature and things, but obviously, because I was thinking, like, there's this human entanglement, like, twins, they touch that at in the womb, right? I mean, they were very close proximity, and I don't know if it's true or not, but I mean, I want to believe it's true. Like, I've seen documentaries where twins who haven't seen each other for years, or maybe not, sorry, not that, but like twins there would be like a twin, they knew straight away when that twin had passed over, and certainly they got the call, right? And sometimes you don't even need to be a twin to have that feeling. Sometimes you just know because your family. But there is definitely something that goes on, I think, between people. There is something that goes on that people feel something when they're really connected on a very, very deep and meaningful level. I think there is something that happens.
Absolutely. I think I think that we as a scientific community are just beginning to understand, I mean, both just beginning to understand quantum mechanics. It's a very new field, but also just beginning to understand really what it means when you try to connect large scale to small scale. I mean, like, you and I, we could get into our moods on a chemical level. Like, you and I could explain, what serotonin does, or how the food I eat affects, like, my gut biome and the chemicals that go to my brain. And, I think that we are beginning to connect the large scale effects to small scales. And I just don't know if we've gotten there yet. And, like, me as a human, not as a scientist, not that they're separate, but, like, my own sort of spiritual take on it is like, quantum mechanics is proof that everything is connected. And I don't need to wait for a science experiment to tell me that that's a way that we're all connected to each other, But I will say that I don't know of any experiments that do prove that, but I think it's simply because we're talking about really small scale and really large scale, and that bridge doesn't really exist yet.
Yeah. And I think, I mean, personally, I feel like that Nobel Prize that they won, I think, like, in a way it has a big importance, because you may feel this too, like, like you were saying, like, that we're all interconnected. I believe that too. I think, like, we are all one. We are all connected to that tree. We're all connected to that person who lives miles and miles and miles away. Like, we are all really connected. And the fact that they were saying about this entanglement on the quantum level, the electrons, I don't know if it's something that you've thought about or not, but this is something I've always felt, like, ever since I was a kid, is that, when let's say you're sitting down now, right? And you look at a short distance. Let's say you're looking at the wall, or if you're looking outside, you're looking at a tree, and there's nothing, quote unquote, between you, right? What I have always seen, to me, it's never been empty, that space. Never been empty. And I know I heard now, obviously, that's what Tesla proved, right? Not Tesla the car, but Tesla the actual scientist.
The man, Nikola Tesla.
The man, yeah, exactly. the real deal. And there's actually, I see all these little, like, they're like little things, like little dots, little lights, particles, tiny, 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 constantly moving. It's like an electric thing. There's no empty space as much as there is empty space. If that makes sense, we can move through it because it's very small and refined, and it doesn't, like the neutrinos, we can't feel them. So I can't feel when I move through the air unless it's strong winds.
Right.
But nothing is, so everything is connected. We're touching everything at all times, I think, you know?
Absolutely. Absolutely. I think
Yeah.
that a beautiful example of that in a physics sense is temperature. I mean, you don't see temperature, but
Right.
it is physical proof that you are connected to the particles in the room because the room has a temperature and that
Yes.
affects your body.
Yeah. Yeah. Oh my God. Yeah, I didn't think about that. That's so interesting.
But I love that.
That's
And I wanted to blow your mind with another consideration.
yeah, go on.
You're like, I'm ready.
Love it. Love it. Go on. Yeah.
Okay, so the edge of the observable universe, casually,
Yeah.
you know how the universe is that we say it's always expanding and things like that. Well, so the edge of the universe, as we define it, is just as far as we can possibly see. So what that means is light from one edge of the universe reaching us took the entire age of the universe to reach us, because you know that light, so sorry, let me talk about like light years, for example. If I say that star is 4 light years away, you know that that means that it would take light 4 years to reach us, traveling at its speed. So there is an edge of the universe that is 14 billion light years away.
Wow.
And that's defined by the fact that light left there when the universe started and took 14 billion years to reach us. Okay. Presumably, that means that there is more outside of what we can see.
Yeah, because it took 14 billion years. Although, how do we know it's taken 14 billion years? Because we weren't around. So how did we measure that?
Yeah, so when that light reaches us, we're able to tell. So the field of cosmology, for example, which is a branch of astrophysics, they talk about the Big Bang and the early universe, and they actually study light, really old light like that, to determine how old the universe is.
So there's a way to measure light, like when you measure the tree, the age of a tree with the rings in its
Yes.
trunk. Okay, got it.
There's a sort of archaeology with light that you
Yeah.
can do in the universe. Yes.
So 14 billion is the oldest light we've seen, but there may be older ones.
Yes, and honestly, if we wait till tomorrow and the next light that reaches us from that area is 14 billion in one day, we have like seen more of the universe, right? Because as time goes on, that light eventually reaches us. There's light in transit towards us from the beginning of the universe all the time. We just haven't received it yet because we haven't waited long enough.
So we have no idea how big the universe is, especially since it keeps getting bigger, right?
That's right. Yes, that's right.
Yeah.
And so, you know, I know that there will be light that reaches us tomorrow that we just haven't seen yet. So it exists somewhere, but it exists outside what I can ever possibly see because tomorrow hasn't gotten here yet. The light hasn't reached us yet. But what that also means is that at the start of the universe, at the start of the Big Bang, all of the things I have not experienced on the other side of that line, we were all in contact.
Yeah.
So even though I haven't seen it yet, I have touched it.
Yes.
And to take that one step further, we can be quantum entangled with things on the other side of that line.
Yes. Yes.
Yes.
So actually, do you know what? I can actually like, it's almost like you could almost say like, this is how you can be connected to, you know, depending on your belief systems, right? You could believe that you're connected to spirits in different dimensions, right? But in a way, if there is a sort of consciousness or a life or something in a really, really far, far away galaxy, right? Then it is actually a very real thing in a way, because there is no empty space ever.
Exactly.
So, and we're all touching. It's just how far are you willing to how far is your touch reaching, basically, right?
Yeah.
Your awareness of the touch, your awareness of the connection.
Yeah. And it's just not possible to be aware of all of those connections, I think, is the other amazing thing. And, you know, it's kind of, to use a really, really shitty example, I remind myself of this when I'm stressed out looking for jobs. And I think, like, you know, I have to remind myself that life is a bunch of moving cogs, and maybe other cogs in other parts of the world haven't moved enough yet to let me move forward. Maybe I'm waiting for a job to open up, but that job can't open up because that other person hasn't left. And maybe that person hasn't left because, their kid didn't get into the school that they wanted to hear back from yet. And, so on and so forth.
Yeah, actually, can I say two things on that?
Yeah.
Yeah, so basically, I'll tell you what a therapist told me years ago. I was desperate for a job, and she said that, oh, that's why I was interviewing and I wasn't getting, anyway, I was looking for work. And she was like, she said, and I was stuck in a really awful job. This is it. So I was really demotivated. I hated my job. And I was actually looking to be an assistant, which is ironic since how I feel about it now. But yeah. So anyway, so she said to me, there is somebody out there who's looking exactly for your skills and what you can do.
Yeah.
You just haven't met them yet. And on the other side, what you were saying about the cogs is, so don't worry, and I can't even ever imagine you now being able to find work. Like you've got all the stuff you've done, all the new stuff. That's just because you're overqualified is what's going on.
No. It's like no one needs an astrophysicist.
We always need one. If I could afford you, I'd have you in-house astrophysicist. Every day we could just talk about this. But then the other thing we said about the cogs is there's this other thing that someone mentioned on YouTube one time. So this is a person who's made a lot of money on YouTube, coaching and things like that, right? And she sells programs through her YouTube channel. Now, she said that before she had all of this money and all that success, she said that she had you told her 10 years prior that she would have made a living by talking to a camera. And I can't remember how else she described it, but she was describing basically her YouTube videos, right? Yeah. She would have not... she said she could never have put this on her vision board because YouTube did not exist back then, or the success on YouTube did not exist back then, however it was, right?
Oh my God, yeah.
So when she was thinking, when her past self was thinking, I need to be making some money, okay? Like, this is bullshit. Yeah. I don't want to be doing this stupid work. I don't know. YouTube was not a thing yet, and definitely not being a millionaire on YouTube was a thing yet. So she did not know that possibility existed down the line.
Yes.
But all of the stuff that she had done up to it existing and I think she was doing videos for a couple of years before it took off. Everything got her ready because on there she talks about her life experience. She helps other people through the hardship she's been through, that kind of stuff, right? So everything led up to it, but she had no idea. She couldn't have put this on a vision board because it wasn't a thing yet. So
that's
like
amazing.
You're saying about the cogs, right? That's what you say about the cogs. Like, you don't know yet. You can wish for how you may want to feel, how comfortable you want things to be, how financially secure and whatever not, right? Whatever other things you want. But you may not know how it would present itself.
That's a really great way to say that. That's exact. And I feel like the people who are really good at manifesting or whatever, I think they would all say the same thing, which is just what you said. Like, you should focus more on how you want something to feel rather than how you want it to look.
Yeah. I mean, I think for me, it's I think everyone's so different, right? I think some people are, and I'm not an expert on those things because I'm still trying to get my things, I'm still trying to get my dreams come true and things like that, right? But I think that, to me, some people I think are very good at they need to speak it out. They'll tell everybody, I'm going to do this, I'm going to create this, I'm going to do that. And when they talk about it, it helps them create it. Whereas for me, it's the opposite. It dilutes it. Well, I have to be very, very specific about who I speak to about it, right? It's just it's for me, it's more about making silent moves. I do the work and I know what I want, but then other things will happen that it will take it into a special direction or look differently, right? But I think everyone is so different, and I don't know why that is. But that's sort of what I've observed.
Yeah, that's a really good point. I do feel very superstitious about it. If I'm waiting to hear back from a job, I don't tell anyone I applied to that job.
Yeah.
And I think it's because I'm afraid that their observation will collapse parts of the wave function.
Yeah, and it could even be the evil eye, right?
Kind
of thing. There are people who believe in that too, right? So I think there is some truth to it. I'm not gonna lie. Like I think there's sometimes, you know, like you can sometimes, you have you ever like been? Are you okay for time, by the way?
Oh yeah, I'm good.
Yeah. We're not going to take too long, but I just wanted, because I just looked at the time. I was like, oh yeah, we went over. But I, because you know, like, have you ever noticed like you can walk into a room and some people's presence tickle you? You know, it's like it's a good feel. It's a feeling. It's like that. You know, like people would say like it's a vibe, right? But it's like it's literally is like sometimes I can feel people like, oh, that just tickled me, just tickled my energy, and other people is like energy vampires. Like it's just like a
Yeah.
drain. Like it's like, oh my god, I have a headache now. Like how do I get away from this person fast enough? Like I can't
Yeah.
leave. Let me leave the room. Let's make an excuse. Like, and it's, so what was I saying that for? About the impact, yeah. And so I think like this, because we talk about, I was saying the evil eye, and I think like some people would almost zap things out of you. And it's not even, I don't even think it's woo woo to say that, because you can really, I can come out of an interaction drained,
Yeah.
and I can come out of another interaction maybe spent because like there was a great debate or great conversation or whatever, you know. So you may feel relaxed, a bit like your body's relaxed, a bit tired, but not drained, right? It's a very different energy. And other
Yes.
people, they'll make you feel alive and energized. So I feel like it's a real thing. Like some, and some people maybe are more
Definitely.
sensitive to it too, right? Like I'm quite sensitive to it. Um, yeah.
Definitely. Yeah. I definitely have had those experiences where something either requires a lot of emotional energy or it gives me a lot of emotional energy in
Yeah.
like a, very reciprocated sort of feeling. Or, as you're describing, like I walk into a room and I can say like, oh my God, that person just evil vibes off of that
Yes.
person.
Yeah, yeah. Yeah. And that's why like there is no empty space. Because how can you even explain that you can feel it?
That's very true. I always wonder that too. And, it's hard. I mean, I realize that like you and I have met as me being a physicist, or, people in my life now meet me and they're like, okay, predominant factors physics. But like before I studied any of this, like I was, a person who had these experiences that I wanted to understand better. And it's impossible to study physics given all these life experiences and not try to map them onto each other. Or, it's not like I was just like born out of the womb understanding physics and then from there like tried to reverse engineer feelings. And so I have to say like very candidly that my experience as a human in this world and then in tandem studying physics alongside it, I think you'd be totally ignorant not to try to put the two of them together.
Yeah, it's going to color how you see the world, right?
Absolutely. Yeah.
Or inform it in a different way, right? Like some things like it just makes sense now because now with physics it's the same thing when I was studying like different topics. This is going back a long time, so I don't even want to mention it, but like it just helped me see the world so differently. Like I find like biochemistry, that's what I just said it now, but biochemistry, like it actually helped me. Like I find like it was so relevant with like finance and economy. It was like it also related, like the whole thing is related. Like
Yeah.
the way we run the world is how our body has been running the whole time, and that's why we have all our answers within. We just need to look within. Like
Oh, that's
our
beautiful.
body's already doing this, like leveraging energy, like and going from oh, I forgot the words now, but anyway, it's just like a lot of it already makes sense in our body, even with things we
Yeah.
can't always explain, like the immune system. A lot of it we don't explain. Is a lot of it is, well, up to like a few years ago, 2018, it was still, a lot of it is hypothesis, but I don't know now in 2024 if it's different. But in 2018 the teachers were very honest. It's like, yeah, I mean, a lot of it's like is theory, really. This is what we think. Like they were not that flippant, but it was more like, a lot of it is what we think is happening, but really, and it kind of makes sense because you can tell how sometimes doctors just don't know how to help you, so
Yeah.
they don't know everything, and that's totally fine. It's totally fine to admit it. They know a lot of things, and I think emergency care is brilliant, but in other things there's definitely a lot of things to learn still, and I think that's exciting.
Yeah, and I think that really the grand thread through you're talking about, micro scale to macro scale, looking at inside us, looking at the way society functions as a whole. In some ways it's kind of like a fractal where it looks the same kind of on every level, and you can go really far in and really far out and it still looks the same. And I think just personally, I think that's because nature is everywhere. Nature's in our bodies, nature's in our interactions, nature is on the scale of the earth, nature is on all of these scales, and nature has these preferences for efficiency and organization. And there's like these sort of rules. And I really think that on whatever level that makes sense to you, you can very correctly apply that to everything else. Like, I think that is just like the tune of nature to do that on multiple levels.
Yeah. Oh yeah. Yeah. I mean, like, if you think about it, like, the last thing I'm going to say on that was like, it's like the body has like, it's got the elements. It's got water, it's got fire, because we have an internal radiator, right? Like
Yeah.
we have a temperature at 37 degrees roughly, or 36, depending. But we have the earth. Like, the way I think the earth is like number two. Like, and I don't say the earth is number two. I'm saying like how we have soil in our body comes out. Because to me, and it sounds so disrespectful to earth. That's not, I didn't mean it that way. But you know what I'm saying? It's like,
No,
when
I
you say
do.
the
I
earth,
get it.
whatever. And then air. We have airways.
That's right. Yeah. Yeah.
And
We
that's
really
it.
do
Like,
have everything.
and we have gold. We have elements of gold. We have iron. We have all of the things. All of the things. We are walking around like diamonds. Like we don't even realize it. We
I
have,
love that.
yeah. So, so Lindsay, is there anything? We've definitely like covered definitely some. I forgot the word now. It's not landscapes. We covered some grounds.
I like landscapes. We've covered a lot of landscapes.
There's been horizons, and yeah. So I know that you've mentioned about how is affected how you see the world. With the quantum entanglement stuff that what they're proven. Is there anything else in like sort of like any other way how it has? I mean, you did already say plenty, so maybe this question now is redundant. But is there any other way how it's changed how you perceive the world?
It's definitely made me more open to possibilities. I want to say that I want to be careful about how I say this in the age we live in now. I think that there's a lot of misguided skepticism towards science, and I'm definitely not advocating for that. But it has also made me realize that a materialist perspective, meaning, limiting yourself to only what physics can explain, might have you miss out on a lot of beautiful gifts that nature is trying to show you, or a lot of discovery that can be very personal to you. So I wanted to at least leave with that thought of keep an open mind, because nature is fascinating.
Yeah, and I think actually that's very conducive to the scientific community's way of thinking, right? Because they know what they know what they don't know, and they don't know what they don't know. And it's
Yes.
right, but it's something that they say. Like, I feel like the science community is very open about that. Like, I've heard other physicists mention this on podcasts. Astrophysicists mention this. Like, it's like there is the unknown unknown. It's like there's certain things that we know we don't know. Like, we don't know how certain things work and things like that. But there are things that we don't know. We don't know what we don't know. And so actually, even they are very open to, well, I mean, maybe not on a day-to-day basis, I don't know. But in theory, they ought to be open, because otherwise, how do you make discoveries, right? If you're not curious as to what is unexplained.
That's right. Yeah. And I think curiosity is the perfect word to stay curious.
Yes, definitely. Definitely. So, Lindsay, this has again been like really incredible talking with you. So I want to end up with the finishing thoughts that I ask every single guest. And I wonder if maybe your answer has changed since last time. But there's two questions. And the first one is, what life lesson do you wish you'd learned sooner?
Yeah. I think this is probably a different one. I don't remember what I said last time, but I really wish that I got into the practice of learning to be with people. I feel like I've always been very focused on my career and not in the practice of having fun, making time for friends, allowing myself to be with friends. And it's a habit. It's a real habit. So my life lesson would be, to treat time and people as preciously as they are.
Yeah. Oh, I think you're not the only one struggling with this. I mean, I struggle with this now as I'm older, not when I was younger, but yeah, definitely.
Yeah.
Yeah, because we feel like we need to be places and do things and we want to achieve our goals. And it's like, but will tomorrow be there? We don't know, right? So it's like, it's this
Yeah.
balance.
Yeah, absolutely. And it's a habit. It's a habit to make.
Yeah. The second one is, what do you not put up with anymore?
I have the Barbie movie to thank. I do not put up with my internalized misogyny anymore.
Ah,
Like I used to like look at girly things and pink things and superfluous things and be like, no, I'm cooler than that. I'm bigger than that, whatever. Like, hell no. Like I want glittery nails now.
yeah. 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 You like it, you tapping into that side of your femininity, right?
Yeah. And embracing it. It doesn't make me any
Yeah.
less legitimate in anything.
No, no, I hear that. I hear that. Yeah. I mean, yeah, yeah, yeah. And it does actually make you different when you've got your nails done.
Yes, it
But
does.
I'm just one of those. I probably get them done like twice a year. I try to do it myself, but like I maybe go because I think it's such a like I think it's like stupid money to go and get it done. Like, and when you do mani pedi, all of a sudden like you're 45 pounds short, and it's like. But the thing is like, and then you have to, and then you tip on top, right? So effectively, you're like, it's just a lot, and it's. But effectively, but then you forget how good it feels after. Like I feel confident when I
Yeah.
go to my to my workouts, or when I'm just at home and I'm seeing my beautiful nails, I'm like, oh, look at that, I'm a woman.
Yeah.
I mean,
Exactly.
I was a woman before, but for some reason it's like now I'm like just yeah. I
It's
mean,
empowering. It's so
it is.
empowering.
It's the little things. So, before you tell us where we can find you, work with you, connect with you, all of these good things, is there anything else that you wanted to share with us that I may not have given the opportunity to?
No, I think this has been an awesome conversation. And I know I've told you this before, but like you have always been one of those people where, like you say, you walk into a room and you just know that this is a great person. Like, even though we met on Zoom, we met on the internet, I knew, and I'm sure that everybody can hear it from you. And I'm just always so happy to spend time with you.
Oh, thank you. I really love your energy too. Like this is why you're back too. Like, I don't ask everybody this. And so, yeah, no, absolutely. Like, likewise, I say likewise. And thank you. I appreciate that.
Sure.
So, Lindsay, where can we find and work with you or find you, like read on your work, give us all the good stuff.
Oh, yeah. So, I think most social media is kind of dead now, which is probably why you only know me through LinkedIn. But my life has been. So yeah, follow me on LinkedIn. More than that, though, I do keep a personal website. It's just Lindsay DeMarchi just lindsaydemarchi.com. That's LINDSAYDEMARCHI.com. If you can't find that, I know Angie will have it in the show notes. And there is a page that I have included. I love working on artistic projects. If what we talked about today is like right up your alley, or if you've got similar things and you're just kind of looking for an added pizzazz from the physics world or the astronomy world, hit me up. I don't care if it's fan art. I don't care if it's a Netflix show. I don't care what scale it is. The universe belongs to everybody, and I want to unlock it with you. So please don't be shy about reaching out about your creative projects. I would love to be a part of that.
Yeah. Oh my God. Yeah. Do reach out to Lindsay. Like, 'cause I love how you make it. Like, you make science so accessible as well. Like, it's just, and you've got this philosophy because you're a poet, right? You write poems, so you've got this side to you. You've got both universes almost.
Oh,
Yeah. You're a multiverse.
I love that. You're a multiverse.
Thank you so much, Lindsay. And I really hope that you come back again. I'm sure we'll find like another topic we can discuss. I would
I'd
love to have
love
you
to.
back. Yeah. And look, I definitely recommend like following her on LinkedIn. Like some of the articles she puts out are really, really interesting. And that's how I get to find out as well what she's up to. So it's really interesting. I genuinely like it. You're probably the only one I reshare on my LinkedIn. 'Cause I don't really do social media either. And
Yeah.
I don't really know LinkedIn that well, though I've been on there for a gazillion years. But you're probably one of the only ones I actually sort of like reshare. I don't really reshare anything on there. So
Wow.
yeah, no,
That's
I
an
really like
honor.
your stuff. Yeah, I like your stuff. Good stuff. Well, until next time, Lindsay.
Yeah, thank you for having me, Angie, and I can't wait to come back.
Me too.
Bye.
Bye. And that's our episode. If you enjoyed it, please share it with a friend. It can be a screenshot that you text them, a link, the name of it, any of those will do. If you give a 5-star rating and a review, that really, really helps the algorithm for it to be shared on all the different platforms. And just a little note, please be aware that this podcast is always free to listen to. Any platforms that want to charge you for it are doing so without my consent, okay? This is free. You can listen to it on Apple, Spotify, all of the other regular listening platforms that don't charge you. This is free. So don't let someone charge you to listen to my podcast. Until next time.
Using health inappropriately.